grad schools that I could apply for, but I don't know which ones I should choose. I don't know which ones will accept me.
Don't worry, for we have a program that can fix that.
Really?
Hi guys, this is our video presentation for the graduate program recommendation system. For students wishing to take a step further in their academic careers, information asymmetry will be a severe obstacle for graduate program applicants, since the compatibility between student status and school requirements is hard to measure. Thus, we would like to build a graduate program recommendation system that provides individual applicants with the prediction of the admission decision, giving students attributes and the schools they're applying to. First of all is an overview of the dataset. There are over 53,000 roles and 26 attributes. Attributes indicating personal information are dropped, attributes with overlapping information are dropped, and attributes with too many missing observations are dropped. Also, inconsistent values in GRE scores and GPAs are converted using the same standard. However, after using the conventional one-hot encoder on all categorical variables, the number of total variables exploded, which leads to extremely slow model training performances and a problem of multicollinearity. Thus, we came up with the idea of using word-to-vec library, which is essentially a word embedding technique. For the attribute major, there are 244 unique values, but many of them have overlapping semantic meanings. We converted all unique values into some semantic meaning groups and used the vector of length 30 to express their semantic meanings. As we were thinking about using the same technique on other categorical variables like undergrad college and university names, these school names just do not have any internal relations in terms of semantic meanings. So we'll just go back again to use the one-hot encoder. After the data processing, we visualize some attributes of the data. As you can see there, with respect to university names, universities such as UCSC and California Institute of Technology are looking for applicants with more industry experiences. And schools like Princeton University and UNC would tend to look for applicants with more research experiences. And almost all the schools requires a high college GPA. However, as we are looking at the key attributes conditional on the admission decisions, we found out that we cannot really tell the difference between the admitted applicants and the not admitted applicants, which indicated that there are other hidden and intangible measurements that are making an effect in those decision processes.
Okay, we then perform the models feeding and analysis. Some of the models we learned in the class, such as the logistic regression, KAN, and support vector machines. And then we also did some research about the new models, such as like GBM and naive Bayes, and the voting machine, of course. And for the logistic regression, we got a test accuracy of 68%. We can see the top 10 largest coefficients here are the numbers and the major with a number. The numbers are represent the program's names or the school names after the one hot transformation, and the major with different numbers represents the different majors. So from here we can see that the admitted decision is basically depends on the programs and the majors. From the KN model, the light colors represent the truly predicted observations, and the dark color represents the predictions that are wrong. And we can see the final accuracy 58%, which is like barely better than the random guessing. From the SVM model, the RBF kernel has the largest coefficients of 70%, and the sigmoid kernel has a 55%. We then perform different sets of parameters for the tree methods for the max depth, mean sample split, and the mean sample leaves. And then we perform the research to find the best parameter. However, our final accuracy is still like 67%. And we then compare the accuracy across all models. We observe that the neural network and the voting classifier and the light GBM has a better accuracy. Unfortunately, they still have the more than 70%. So for the future work, we need to understand the mechanisms of voting classification and interpret the model. And we also need to perform the data processing and find a better, with high accuracy models, because our current test accuracy is not high enough. In conclusion, our low accuracy reflects the data is not comprehensive enough for graduate program application system. This is because some intangible measurements, such as research and internship quality, statement of purpose, and school reputations. For the school reputations, for example, some schools may have some higher rank in some majors or careers. So we need to change the data for those schools with higher weights. Thank you for listening.
So someday I might be able to use this program to figure out which graduate school I should apply to, which I have the best chances of getting in.
Yes, in all due time.
Cool. I'll be sure to use that one day.